Alright, so we're in the second part of our Unit 5 project. We're given that wheelchair ramps require specific ratios of height to length to make them usable by people who use wheelchairs. In this project, you'll investigate the angles and distances of these ramps. The Americans with Disabilities Act, ADA, requires a slope of no more than 1 to 12 for the wheelchairs and scooters for business and public use. Consider the following problem. The Pet Plus outlet is redesigning its entrance as represented by the following figure. It has a ramp that is 15 feet long. The ramp should make no more than a blank angle with the ground in order to comply with the ADA. We will solve this problem step by step. Alright, so first we want to find the lengths of the vertical and horizontal legs of triangle ABC. If the slope of the ramp is exactly 1 to 12, what answer choice correctly represents approximations of length CB and length AB? Since we're giving these approximations, we're going to compare the height to the length and match it to exactly what that proportion would be for our ADA ramp. So we are given that this is the height to length for the ADA is 1 to 12. So this is our height and this is our length. So I'm going to set up a proportion of height compared to length, so which was 1 divided by 12. And I'm going to check, does that equal what they're giving me? And so the first one, they're saying that CB is approximately 18.6852 feet. And I'm going to look, CB would be considered the height. So I'm going to mentally note that this is the height and AB is the length. So then I'm going to set up my proportion of CB, which is 18.6850 divided by the length that is given, which is approximately 1.24568 feet. And we're going to simplify those and see if they are exactly the same decimal. So does it reduce to be the exact same? So 1 divided by 12 is equal to 0.083, like we found out in Project 1. So 0.0833 repeating. Does that equal 18.68250 divided by 1.2456850 divided by 1.24568. That's going to give me 14.997, which is not 0.83. So this first one is not equal to it. So then that option is off the case. So now we're going to set up our next ratio of height to length in a proportion. And it's given that CB is our height is approximately 1.24568. That's going to be divided by the length of AB, which is 14.94816. So now I'm not going to divide 1 divided by 12 again because that proportion of height to length does not change since it's the ADA's ruling. So now we're going to type in 14.94816 and divide it by 1.24568. Whoops, I did that backwards. I apologize. It needs to be 1.24568 divided by 14.94816. 0.94816. There we go. It's 0.83 repeating. Since it does equal exactly what the ratio of 1 to 12 is, then that's going to be the height and the length that PET plus outlet needs to use. That's how you can compare how to find the height and the length of that for a 15-foot ramp. Alright. So now, the ramp should make no more than a blank angle with the ground in order to comply with ADA. Alright, now when we're trying to find an angle, we are going to use inverse trig functions. So in my notes, I would write, find side lengths, use trig functions. To find an angle, use inverse trig functions. So then, I'm going to mark on here what we were given. We were given that CB is 1.245868, and side length AB is 14.94816. Alright, and they want to know the angle of elevation. And I'm going to remember that the angle of elevation is formed from the ground, between the ground and the ramp. So it is formed between the ground and the ramp, which is our angle A. So angle A is going to be our perspective. So if I'm looking at angle A, I want to know what ratios can I create. Now, since we have all three sides of this triangle, we could create every single inverse trig function. So we could say sine inverse of, what's our opposite side, which is CD, over the hypotenuse, which was AC, is going to equal our angle, and angles are represented by theta. So, or I could set up that cosine inverse, cosine's ratio is adjacent, which would be the length of AB, divided by our hypotenuse, which is length AC, and that's going to equal our angle. Or we could set up the tangent inverse ratio. So tangent inverse is going to be opposite, which is our side length CD, divided by our adjacent, which is side length AB. And that could equal our angle. So now when we go down here to check, we're going to check which one matches. So we had sine inverse of CB divided by AC. Yes, that could work. Sine inverse of AB. No, AB is our adjacent side length. Or could it be cosine inverse of AB divided by AC? Yes, that is our adjacent side compared to our hypotenuse side ratio. So those two would work. Now, the ramp should make no more than a blank angle to the ground in order to comply with the ADA. Solve the algorithm you chose in the previous question and enter your answer rounded to the hundredth. So if we go back to our calculator, if you notice it has this inverse right here, we're going to have to click it, and then you'll see inverse, sine inverse, cosine inverse, and tangent inverse. So choose which one we wanted to use, and we're going to use our substitution property. So I'm going to just say, okay, I'm picking sine inverse. as the function I'm using. So I'm going to use the substitution property. I'm going to have sine inverse of the length of C to B was 1.24568 divided by the length of AC, which is 15. Now that will give us our angle theta. So now I'm going to hit sine inverse, and arcsine is another name for sine inverse. So please just make note of that. Arcsine is the same as sine inverse. It's just another name. So it's like calling red rojo in Spanish. They're both the same color. They just have different names because they were spoken in a different language. Now, arcsine was created as a label for sine inverse by those that didn't want to use the exponent to the -1 because they thought it looked too much like an exponent. So there was a debate in math as to how it should be labeled. And one branch decided arcsine, and one branch decided sine to the -1. They both represent the same thing, though. So now I'm going to have arcsine, or sine inverse, of 1.24568 divided by 15. And that's going to equal 4.63. degrees, since I was in the degree mode. So our angle should be no more rounded to the 100th. Okay, so rounded to the 100th. 6 is the 100th. So I'm looking at this 3 and I'm going to ask, is that 3 4 or less or 5 and more? And it's 4 or less. So that means 4.763 is closer to 4.76 than it is to 4.77. So our angle is going to be 4.76 degrees. Explain the steps you took to solve questions 1 and 2. Be sure to support your decisions using mathematical reasoning / justifications. Alright, so now let's review. How did we go through solving what we did? And step 1, we set up a proportion that compared the height to the length for the ADA, and then set up that same height to length proportion and check to see if it reduced to be the same decimal. So on step 1, we used proportions. We used proportions to check the height to length given from the ADA, which reduced to 0.083, repeating. And set up the same proportion of height to length from the given options, and found which one reduced to exactly 0.083 repeating. So that was how we found our height and our length. Step 2, how did we solve step 2? Well, we first identified, so in step 2, we first identified the angle of elevation, which was angle A, and then we labeled And we labeled the side links with the given information we found in problem 1. Then we set up the inverse sine ratio. So we set up the inverse sine of length sine is opposite over hypotenuse. So opposite was length CB over hypotenuse length, which was AC. Length of CB divided by the length of AC. Then we set up, I'm going to edit this, then we set up all of our options for solving for angle A, which were the inverse sine of, and I include parentheses over here, inverse sine of our length CB, length CAC, and then we set up also the inverse cosine of length, which was our length of our adjacent side, AB, length AB divided by the length of our hypotenuse, which is AC. And the last one we set up was our inverse tangent, so inverse tangent of length. Tangent is opposite over adjacent, and the opposite side is CB, divided by the length of our adjacent side, which is AB. Then we decided which one to use, and we picked inverse sine of length CB divided by length AC, and using, also then we use the substitution property of equality to write inverse sine of parentheses 1.24 568 divided by the length of AC, which was 15. Then we made sure the Google calculator was in degrees and inverse. Then we typed it in and rounded to the nearest hundredth. So those were the steps that we took in order to solve our questions. And now we're going to save and exit, and I'll see you in the next one.